Right, in this video, I want to get a little bit more mathematical about the description of heat. Um, so first and foremost, as I mentioned in the previous video, heat is an energy transfer. Heat is an energy transfer. Now, that should remind you of something that we said not too long ago in the course, which is that work is also an energy transfer. So heat and work should very much be viewed as, brothers of each other, that they are both ways that energy can be transferred from one place to another. The difference is work is a mechanical transfer of energy where you are physically moving the energy from place to place, whereas heat is happening at this kind of random microscopic level because of differences in temperature and things like that. So this field is called thermodynamics, the study of heat and thermal energy and all these kinds of things. So the first law of thermodynamics is that heat and work and energy are all interrelated with each other. And specifically, the way it would normally be written, by the way, if you ever look at any other sources for this, there are some confusing sign issues, which I'll explain in a second. But the way I'm going to write it down, which to me is the most easy, consistent way to write it down, is delta E represents the change in the energy stored inside of a material equals the amount of heat that flows into that material plus the amount of work that's done on that material. And let me clarify those definitions, because as you remember from the work section of the course, you get into this whole sticky issue of positive and negative sign with work, because it kind of depends on, like, are you talking about the work done on the material or the work the material is doing on another object? You run into a similar issue with heat as well, where are you talking about the heat flowing into the material or are you talking about the heat flowing out of the material? Okay, so E is the energy stored within an object. Q is the heat flowing into that object. And W is the work done on that object. Because remember, work done on an object is the energy that's flowing into the object. So the key thing here is I've used consistent definitions for heat and work so that both of them are positive if energy is flowing into the object, and both of them are negative if energy is flowing out of the object. So everything is positive in the first law of thermodynamics. Okay, so that's the first law of thermodynamics, that there are two ways you can change the energy of an object. You can either bring energy in mechanically in the form of work, or you can bring energy in thermally in the form of heat. And I might as well throw into this video as well, how do you actually put heat into a material? Well, there's a couple different ways. The easiest one to understand is, let me write down the equation first, and then I'll explain it in this case, that the amount of heat is the mass of the material times C, which is referred to as the specific heat of the material, times delta T. Okay, this is another key equation that we'll be using a lot. So let me explain carefully what it means. So Q is the amount of energy flowing into an object. M is the mass of the object. C is the object's specific heat. So now, what is specific heat? Specific heat is a property of what the material is made of. So like you can look up a table, there's a specific heat for iron, there's a specific heat for copper, there's a specific heat for bone, there's a specific heat for whatever, every material that you might want to name. And that specific heat tells you how much energy can that material absorb before its temperature starts going up, basically. How it tells you how much energy a material can store given its temperature. So something that has a higher specific heat, it takes more energy to heat it up, and then it'll give off more energy as it cools down. So that would mean a higher specific heat. So I'll just write in parentheses here, more energy required to heat up this material. That's what specific heat means. And then the delta T there represents the object's change in temperature during this process. So in other words, what we're visualizing here is a process with a definite beginning and end. During that interval, Q is the amount of energy that flows into the object, and delta T is the change in the object's temperature. And you'll notice, by the way, delta T will be positive if Q is positive, because energy is flowing into the material, causes its temperature to go up. And delta T is negative if Q is negative, naturally, because if the temperature is going down, energy is being given off by the object. So negative Q means energy is given off by the object. Positive Q means energy is absorbed by the object. And if the object is absorbing energy, its temperature will go up. If the object is giving off energy, its temperature will go down. So that's one way that an object can exchange heat with its environment. It can do so by raising and lowering its temperature, to basically raise its temperature to store the energy or lower its temperature to emit the energy.